problem I posted on Facebook, and I promised my viewers that I'd have the solution on YouTube. It's basically a quarter circle with a right triangle, and it's the 3, 4, 5 triangle, but the blue area is what you're supposed to find the solution for. This particular problem is a little more complicated, but it's easier than you might think. The first step when doing this problem is to think about the two parts that are going on. The first part is the 3, 4, 5 triangle that is 2 points up on the circumference, but if you bisect a chord, it'll always intersect the center, and that's what's going on in the first half. The second half, the other triangle, which is QBC, that triangle, if it's a right triangle and the hypotenuse is the diameter of a right triangle, the right angle will be on the circumference of that circle. So here we have circle N. It's the center of the hypotenuse, and we bisected it, and as we can see, the green circle around it intersects point C. So we have a bisector and we have a circle, and they both intersect at the same point. Now it's real simple. We just use a little geometry. We do similar triangles to find out that MN is 3/2. Then we use the Pythagorean theorem, and we find out that BQ is 5. And then from there, we have that inscribed right triangle. We find out that NB is 5/2, and that's NC is 5/2 also. We add the two together, so now we know that MC is 4 units. So the blue line is 4 units, the blue segment. We use the perpendicular bisector. That bisects PB, and so that gives us a distance of 2 for MB. And then we use the Pythagorean theorem twice, and we discover that QC is square root of 5 and BC is square root of 20. So we have our base and our height of the shaded region. So area equals 1/2 base times height. Area equals 1/2 square root of 5 times square root of 20. Square root of 5 times square root of 20 square root of 100, which is 10, and half of 10 is 5. So the solution is 5. The shaded area is 5.